Good afternoon. This is Kevin Askew, Senior Sales Manager at Programmer's Paradise. I want to welcome you to today's webinar by Embarcadero, Leverage Cloud Computing Architectures, Storage and Services to Build and Deploy Distributed Applications. Today's agenda will include a brief introduction to Programmer's Paradise, followed by the webinar Leverage Cloud Computing Architectures, Storage and Services to Build and Deploy Distributed Applications by David I., VP of Developer Relations and Chief Evangelist from Embarcadero. We'll end the session today with a question and answers period and a summary by David. Programmer's Paradise is a leading e-seller of developer and infrastructure tools. We can be found on the web at www.programmers.com. We are an Embarcadero reseller covering products from RAD Studio, JBuilder, DB Artisan, and ER Studio. We also offer team development services around assessment, deployment, and migration. Our ALM worldview includes industry-leading tools for your end-to-end development needs, including defining, designing, developing, testing, deploying, and managing. Without further ado, I will now turn things over to David to begin today's webinar. David?
Great, thank you very much, and thank you to Programmer's Paradise for letting us give this presentation, and thank you all for attending. Here, I tried to come up with one of the longest webinar titles I could, but really this presentation and demo is all about understanding a little bit about cloud application development and cloud storage and how to use them in the applications that you need to build. That's enough about me. I'm a longtime programmer. Been here at Embarcadero and the incarnations of Borland in the past. There'll be my 26th year next month. I'm passionate about programming, and I'm a cheerleader for programmers. So if you need cheering up or cheering on, I'm here for you. David I. at Embarcadero.com. Again, we're going to talk about some of the things going on in cloud computing and cloud storage and how to build different kinds of applications using our RAD Studio product. We have components built in, and of course, if there's an API out there that developers can grab, then we can interface to it as well. You might think about different kinds of questions. You know, what is this cloud stuff? Should I use a public cloud, a private cloud, maybe cloud architecture that's inside and outside your firewall, or a hybrid cloud? Should you use cloud storage or keep your databases inside your firewall? That's your choice. How do you get started? And you can always post questions for us in the Q&A area, and we'll get to those at the end as well. There was a white paper by a gentleman from IBM, and he took the lyrics from the song Both Sides Now by Joni Mitchell. It's Joni Mitchell, one of my favorite songwriters and singers as well. And so, you know, if you look at Both Sides Now, what is this whole thing about clouds? Do we really know clouds? And there's so much going on in that whole world. In many cases, it's just another place to run your applications and a bunch of APIs to use. And again, for me as a developer, if there's an API that I can leverage, I love it, because that means less code and less architecture and less hardware that I have to deal with. As I mentioned, there's different kinds of clouds, different types of clouds. You can use a cloud kind of architecture, cloud storage inside your firewall. For example, you could take, you know, if you had an Apache server somewhere or a Linux server, you could put Hadoop or another NoSQL inside of it. You could use a public cloud like Amazon's Elastic Cloud Service, EC2. You might use some software infrastructure outside your firewall. You might use the Google Maps API, for example, or Google Doc. You might, at our company, we use Salesforce.com in our sales group, and we use Eloqua for our marketing, and those run on hosted services outside our firewall, but we still keep our customer database and other things inside our firewall, so we're sort of a hybrid cloud organization as well. There is some movements about how to come up with either standards or better understanding and better knowledge sharing about cloud architectures and cloud development and cloud use, cloud operations. There's an open cloud manifesto with a lot of vendors and individuals who are signing on to to help move cloud computing forward and also make sure that there are choices, that there's not just one vendor, that there are lots of solutions that you can choose from. So you can move your applications or maybe run parts of your applications on multiple clouds, for example, especially if you're thinking about will that cloud operator continue to be in business? What if a data center goes down? Same kind of things, of course, we think about when we're developers even using our own network systems inside of our firewalls. What happens if a server goes down? What if a drive dies? What if our database gets corrupted? What if one of the processors blue screens, for example, which happened to us the other day? Well, these things happen, so we have to make sure we architect and plan for these kinds of issues. And of course, getting the knowledge built up that we can all share means that there'll be more skilled professionals who know how to leverage and use cloud computing infrastructures and architectures and the services of cloud computing. So go and check out opencloudmanifesto.org. There's many different aspects, or I use the term facets, when we think about cloud computing, and many of these are the same things we think about when we're building applications and architecting and designing and gathering requirements of the multi-tier and distributed systems that we build today. Just now we have even more choices in a sense as a commodity or a utility sitting out there. So of course, we want to be able to run applications, we want to be able to leverage services, and if there's APIs, boy, if they're really good APIs and they do the work we need, why would you want to rebuild something? For example, would you want to build a Google Maps or a spreadsheet object when you can just leverage all the things that are already out there? Of course, we deal in data. Sometimes it's a data stream, sometimes it's a database, and then we have to decide, well, is that database a local table of some kind? Is it a SQL database? Which vendor? Is it a NoSQL database, or is it some kind of alternative data structure? And so these are aspects we want to look at when we're thinking about building applications in a cloud architecture, and again, in whatever architecture we're dealing with and whatever topology that we're dealing with. There are some things that are specific to a shared data center, and for that matter, a shared machine, like a virtual machine or a shared processor system. What about security? And of course, we should be dealing and thinking about security all the time, even if we're inside the firewall, even if we're on our desktops. You know, if we're handling sensitive data, it's either required that there be secure access and secure control over data. For example, health data, personal credit information data, social security numbers, or other kinds of things. And different government organizations in different countries have different levels of privacy and security that you must adhere to, and that you have to monitor and even deliver reports on what you're doing to make sure that you're secure. And of course, some of you, if you've got a PlayStation, know that Sony's PlayStation network got hacked. So it's not just the little companies; it can happen to the largest companies on the planet as well. If you're going to be sharing some hardware, sharing storage space, sharing processor space, even though you can be isolated as it relates to your operating environment, but you're also on machines with other people. So thinking about what does it mean if I'm in a multi-tenant approach. So think about an apartment building or a condo building. You have your own space, but of course you share some of the infrastructure and some of the housing of it with other tenants as well. Of course, I mentioned governance and how do you manage these systems. What does it mean to deploy these applications or parts of applications? When we build software and we have an installation kit, then we hand a DVD or CD to someone or a memory stick and say, here, run the setup program or run the install script or run the batch file, and it will do it. So just as we deal with server architectures and multi-tier architectures in our organization, we have to think about what it means to deploy our applications or bits of those applications across the different parts of a cloud architecture. What does it mean to provision? We think about provisioning in our cable modems or our DSL lines. We go to the phone company or the cable company, and they make sure that all the pieces are set up properly. Well, we have to do that as well in our infrastructure systems and in cloud systems. How do you monitor your applications? How do you monitor the systems you're running on? Some of these cloud computing systems give you great monitoring tools and even APIs so that you can, in a sense, instrument inside your applications monitoring. If you Do you want to care about metering? Do you want, in your application, if you're paying, for example, for throughput, do you want to have control over how much is being processed through your cloud computing infrastructure or your application? And of course, being able to log and send out message alerts, whether they're SMS or emails or other things, to be notified when things are going on, especially when the data center's somewhere else in the world. It's not just down the hall where you can go and look at the sort of control panel screen to see what's happening, or you can't always maybe remote desktop into the system. What if you want to leverage multiple cloud architectures on multiple different cloud systems? How do you integrate parts of those systems together? Well, if there's APIs and other things, then you can do it. If there's data integration, you can do that. There are some companies coming out with toolkits and systems for doing cross-cloud integration. And of course, things like migration. What if you want to move from one cloud to another? Well, if they're the same infrastructure, then it's very easy, right? You just almost zip it up and copy it, or tar it up and FTP it or whatever, and then start it up. There are also companies that let you configure the appliances or the packages and pieces that you need, so that they're ready and sitting there so that you can move them and target them to different cloud systems. And there's some companies that are doing that you might explore. And then we should think about, if we're going to explore using one of these architectures, what's the service level agreement of that vendor? Will the system stay up? What if there's failures? What if there's bandwidth issues and other kinds of things? So we have to make sure that we understand when we're going to make choices of systems. Some of you may know, have heard the news that Amazon's EC2 data center in Virginia had some problems a few weeks ago, and I think it was Foursquare and some other companies that were using those servers were having problems, were down for a while. Well, that's why we do failover, right? But we should still understand what's the level of service, what is the level of redundancy, what is the level of backup and other kinds of things, uptime that these cloud vendors are going to provide. Maybe for a price you get different levels of service, for example. And then there's all these, what I call the ill-at-ease, not ill at ease, but ill-at-ease. Scalability, reliability, availability, all those things that we have to think about to make sure that we build robust systems that stay up, that fail over, that can be migrated and moved, that can be updated. What does it mean to deploy? If I'm on my desktop, I just stop the application and deploy it. And the same thing on web servers. Maybe we can just add new pages and update pages on the fly. Well, we're on a cloud computing system. We've got to think about how we can do those kinds of things as well. There's always that question. In these days, years ago, we had desktop databases, DBase, Paradox, and Microsoft Access, and there were many other kinds, your own local data store of some kind. Then we had the SQL databases and SQL engines of Oracle and Microsoft and so on. Now we're hearing about all these things called NoSQL. Amazon's S3, Google's BigTable. Microsoft has Azure, where you can store tables, arbitrary tables. There's Hadoop from the Apache Foundation, storing key value pairs, or maybe it's tuples. So Anders Olsen, who works with me at Embarcadero, found this bitmap online, and here the guy's working on his resume, and his friend is helping him, and it asks, do you have any expertise in SQL? And he says, no. It says, okay, write in expert in NoSQL, right? And then now you're a NoSQL developer, and you can look for those kinds of jobs. Well, now we think about architecture in the cloud. It's oftentimes the same kind of thing we think about in architecting multi-tier and distributed systems inside of our firewall and in the systems we've been building in recent time. When we think about the infrastructure, we think about our servers and our clients and our business object servers and so on inside of our company. Well, think virtualized hardware. Think VMware, Amazon EC2 Cloud. You've got some storage, you've got some processing power. I think Amazon now is even renting out time on some NVIDIA, Tesla GPU servers. So if you need some intense graphics processing or data processing, you can fire off those. IBM will sell you time on their Blue Gene high-performance computer. At the API layer, think application frameworks and APIs for the cloud infrastructure and for storage infrastructures and things of that kind. And then all the services that we use. Think, SQL Server from Microsoft. It's called SQL Azure. It's the SQL Server in there. App Engine, Data Store from Google, database.com is going to give you an access. We're putting up all sorts of SOAP servers and RESTful web services out there as well. So if there's services and storage systems and they have APIs, things we can do to leverage them, that should fit into these layers of our cloud architecture as well. Our product RAD Studio offers many solutions. It supports the Delphi programming language, the C++ language, .NET 3.5 and 4.0 with our Delphi Prism product, and PHP, which you can run just about anywhere with our RAD PHP product, to build desktop applications, web applications, service applications, multi-tier applications. And this is where cloud can fit in. You can have your own servers, you can have web servers, but you can also, and we have direct support for deploying applications to Amazon EC2 and for doing processing in Microsoft Azure. Microsoft Azure with its tables, blobs, and message queues. And we'll be adding connections to other cloud architectures in the future as well. But if there's an API, of course, you can do that work today. We use our DataSnap and leverage our DataSnap technology. Our DataSnap technology allows you to build reusable native code servers in our Delphi and C++ builder programming languages and deploy those to Windows desktops and Windows servers out in the cloud or in your own infrastructure. And then you can build clients in many different things. You can build a PHP client and talk through RESTful interface to pass data packets and make method calls of these remote objects. You can use Delphi Prism on .NET. You can use JavaScript and HTML on a web or browser-based or browser container type application. And then you can talk through our database architecture to get at the methods and interfaces of these DataSnap servers. And so building a DataSnap server and putting it out on a cloud application server so that you can call its remote methods. And in programming, we write code to do calculations and loops and blocks and things of that kind, and we call functions. So in our world, it doesn't matter whether that function is local on your machine, in a DLL, in a shared object, in a dynamic library, or that method is running on a server somewhere and you simply call through TCP or HTTP and pass the name of the method and the parameters to the method, or pass object instances over to it. It can do its work and it can send the return result, or it can just do what it's supposed to do and tell you that it succeeded or failed. And the DataSnap architecture is generalized into a whole bunch of layers, and I won't go through all of these layers, but a lot of it's in there. Things like, the application level methods. That's what you do as a programmer. You build methods, build functions that you want to deploy out to these application servers. You want to be able to administer those objects and those servers. You want to be able to pass different kinds of objects and types back and forth. Pass object instances and have the infrastructure do the marshalling and put it all into JSON packets and send it over and then pull it apart on the other side so you don't have to do any of the marshalling of it. You want to be able to have authorization and control over who can call your methods. And so that's all built into our DataSnap system as well. And you can choose the protocols that you want. HTTP, HTTPS, TCP/IP. You can house those objects inside of web servers or just on servers or processing machines, whatever they might be. And again, from the developer standpoint, it looks like a bunch of objects and a bunch of functions to call. And the infrastructure of DataSnap does all the undercover work for you, so you don't have to do anything but just make a function call, pass some parameters, get the result back. In our technology, we got there by starting with COM and DCOM and what we called our Midas distributed architecture, where you could sit on Windows and build that. It had load balancing and allowed you to build thin clients and do connection pooling and all those kinds of things for doing data and database operations and method calls. And that was tied to COM and DCOM. We then continued to add to it, and in Delphi 2007, we said, okay, if you don't want to use COM, then you can use TCP/IP, you can use HTTP. And then we continued to add support for multiple programming languages. So you can build clients in Delphi, C++, PHP, and Delphi Prism on .NET, and have clients that talk to these DataSnap servers, wherever they are. So you can still use the COM-based, DCOM-based system if you're completely in a Windows environment, but you can also branch out and talk with clients through many different mechanisms. And in our RAD Studio XE, we now have DataSnap XE, which gives you a full REST framework, proxy generator, so that you can create a proxy for other programming languages. Maybe you need a Python proxy, or you need a Ruby client that talks to a DataSnap server. You can generate the right JSON packets and the right types of method calls. We provide proxy generators for Delphi C++, Delphi Prism, PHP, and for JavaScript HTML. We have lightweight callbacks, so the client can tell the server, send me something when you're done. Do an asynchronous callback back to the client. We also have in XE now these things called heavyweight callbacks, where it opens up a channel on whatever protocol that you're on, and you can just pass JSON packets back and forth between client and server object, and then just listen for those JSON packets coming in. So as long as you're connected from client to a server object, then the DataSnap technology will signal you when packets come in so you can process them. And again, it uses a role-based access control using attributes. You can decorate a class or decorate the methods of an object to say who can access this. Is it administrators? Is it specific users? You can set up those roles and the people who are associated with them, so you can hide interfaces and not allow certain people who don't have certain levels of security or certain levels of rights to call some of the methods, versus having objects out there that have all the methods. You can also encrypt the packets going on the line, and you can use HTTPS and SSL down at the link layers as well. So lots of levels of security that you have full control over as a developer. We have wizards to get you started. Just file new, choose a wizard, build a REST server, a SOAP server, a web server using the DataSnap technology. And you can build just turnkey applications that happen to use TCP/IP or HTTP underneath as well. So it's your choice. You don't need to have a web server infrastructure. You can have, in a sense, a web server running as an executable listening on a port. And this screenshot just shows, you'll see some examples in a bit, where you start up your application and it just starts listening on a port for method calls from your client going into your server. So this is our Indie web broker application type that's part of RAD Studio XE. I mentioned Microsoft Windows Azure. That's their cloud infrastructure, part of their cloud infrastructure and strategy. In Azure, they have SQL Server running in Azure. You can use that. It's called SQL Azure. They also provide 3 other levels of storage, a blob storage, so you can store videos and bitmaps and arbitrary blobs of data or text or whatever it might be. It's unstructured storage. You define the container through the API, and then you send the bytes to that container. They have tables. These are arbitrary tables. Think of NoSQL in that world. They're entities. You'll see that in the demo, where you have a name and a value and a type, and you can store these entities in the table, and other applications can pull them out and do something with them. You build up whole customer tables, for example. And they have their Microsoft Message Queue as these queues that run in the storage, where you can store up to 8K worth of data into each message inside of a message queue. And then you can have other applications that are pulling things off the queue and processing them. Maybe it's orders and customers, and you're going to go and do the back-end processing on them. It might be some kind of automation coming off a factory floor, those kinds of things. And we give you the full access to the Microsoft Azure API, as well as we give you some components to make it just easier to get at all the different aspects of Azure. But you have your choice. We have an interface unit and the components. And this little window here shows you the built-in components, the connection component, the blob, queue, and table management components that we provide. For deployment, for Amazon EC2 in RAD Studio XE, we have, in the project menu, we have a deployment system where you can log on by your username and password of your Amazon EC2 instance. You might have multiple instances on multiple machines running around the world. You can define the files that you want to deploy, and then periodically after you do builds or as part of a build process, you could do a incremental deploy. or dynamic on-the-fly deploy as you're doing things, just by going on the project menu and saying, let's deploy after you've set up your connection. And you'll see what it means to create an instance as an Amazon and then manage it as well. Amazon's storage system is called S3. And there you just store bytes, and the bytes might be a bitmap. Like here's a picture of a triggerfish that's, and I'll give you the URL in a little bit, and you can all get your browsers and go and look at triggerfish, for example. It's just a set of bits that are stored in the S3 table. You can have objects that you store in S3 that are from 1 byte to 5 terabytes. Of course, they're going to charge you the more storage that you use. They're organized into these things called buckets, and you can use the API from Amazon S3 to store and retrieve buckets. You create your developer key when you log on and join Amazon's web services system, and then the interfaces are just API calls through REST and SOAP. So it's something that we as developers have known how to use for years now. Google has their BigTable system that's used and underpins a lot of the stuff like Google Maps and other things. You know, name value pairs, you can store things into it. And again, you can leverage that in applications where you need to store different kinds of data. Most of these systems are key value pairs, or they might be a tuple, you know, a 3-element storage element where you might have a key and maybe a type or something else, and then the data that's stored in it. So take a look at the world of NoSQL and see what kinds of systems that are out there. Many of them open source and many of them freely available. So we're thinking about building an application in the cloud. There's many different ways. What's your client? Might be a desktop, might be a phone, lots of phones. Foursquare, for example, has their system running in the Amazon cloud. Use your phone, use your browser. You can get in and do things. Maybe there's a web server. Maybe there's just an object server or an application server that's looking for requests, method calls, and so on. And then it's going to do something and send the results back. Or maybe it's going to return a page. You know, it might return HTML5 and some CSS back to the client if it's a browser client. Or maybe you're building an application, a desktop application, that has an embedded browser client, an HTML engine and a JavaScript engine as part of your runtime. And you're never actually going to use a browser. You're just going to use HTML5 and CSS as your user interface. And there's been articles recently to show people how to do that as an alternative to calling Windows APIs or calling iPhone APIs and things of that kind. You'll have your data server. Maybe it's serving up business objects that are getting data from a traditional SQL database system. So you might run all or parts of this kind of a thing in the cloud. So what I'm going to do is run through about 20 minutes, I think it is, of some demonstrations. Then we'll get to summary and Q&A as well. And because of the bandwidth and the setup here, I'm gonna run this by sharing my desktop, and then we'll all sort of watch it, and then we'll come back to finish it and get to Q&A. So we're going to go through some working with Microsoft Azure, Amazon S3, EC2, and these. I'll come back to this slide after I share my desktop, but if you want to get ahead of the curve on a couple things, you can point your browser at a couple of those IP addresses, but we'll come back to those again later. And you can see a DataSnap server running in Amazon EC2 in action, or a customer application that's using jQuery and passing JSON packets to display those using HTML in a browser or browser container application. So those are the IP addresses that are of these EC2 instances. The first one's running on the California Amazon data center, and the second one is running in the Ireland data center. All right, so just give me a quick moment to switch view to my desktop, and I will do that. Hold on. Hopefully there it is. It's letting me do it. I've got RAD Studio running, and it's it's got Delphi and C++, and I'm using RDP to get to that desktop. I've got Firefox running, and I'm logged into my Amazon Web Services console, and you have several things you can do from the console. If you've got some buckets in the S3 storage system, then it says, okay, I've got some data buckets, and
There's the data bucket. Looks like I have a picture that we can stick things in. I've got another one here that doesn't have anything in it right now, but we'll stick some things in that bucket later. And we can go and change the properties and do all those things. The other part that I'm going to use is I used Amazon EC2 Elasticsearch. They've got different, so here's the new Tokyo data center, Singapore, EU West in Ireland, Northern California and Virginia, and they have plans to add others as well. And Microsoft's building data centers. Everybody's building data centers as well. From the control panel and dashboard, I can see I've got a running instance. I've got an elastic IP, so you can actually pay for to give yourself an IP address, and you can assign that IP address to one of your instances or move it to a different instance. For my instances, in my case, I've got an instance that's running a micro instance of Microsoft Windows. You can have them configured and provisioned but not started. You can stop them, pause them, and so on. So you right mouse click and you say, do instant management. You can connect to it. In fact, I've got a remote desktop that's getting me to my instance. Remember the password. So here's my instance. It's Microsoft Windows Server 2008. It's called the Micro Edition. It's the base level is 4 cents an hour. So that's about $2 a day. And in here, I've got an application running, which is a DataSnap server for our famous fishback demo. And on this Windows instance, I can actually open a browser and see it running. And here's my application, which is, in this case, going to my local host and through port 8089. We'll talk about how to build that. And it's loading the data and the application and calling from a JavaScript HTML client in the browser to my DataSnap server through port 8089. On this server, I've got a shared folder which has my fishback Indy, it's got my whole project, it's got my executable. So here's my remote now, and you can hit this as well. So all of you that are out there, bring up your browser, whether it's Chrome or Mozilla, Firefox, or IE or whatever. You can hit 184.72.37.150:port 8089. That's the IP address, and you will connect through your browser to the instance and to the application running on my Amazon instance. This is text from a text blob, and the grid is displaying it. And this is an image that's, how do we build this application? So let's start by building a simple DataSnap server. So let's go into File, Other, and we'll go to DataSnap, and we'll build a DataSnap web broker application. We could also build a DataSnap server with REST support and a full DataSnap server and a web broker DataSnap server. Let's go and build a DataSnap server which will have support for JavaScript and JSON. And we can build a standalone VCL. It could be an ISAP EDLL for Microsoft's IIS. So let's just build. Let's give it a port 8085, for example. We can test that port, make sure it's not being used, or you can find an open port. Do you want some sample methods? Do you want authentication built in? Let's just build a simple application with the default methods, and let's save it. Sure, that's fine. Save it out there. So just like you saw in my fishback application, it will give you a nice little interface with the port that you find. You can always change that port. It's just an edit box. And then a button that will execute on the port. It'll do a shell execute to execute the browser and talk through that port, whatever that port was that we defined in the edit box. And then we've got some other methods. There's two methods that the wizard generates by default, an echo string and a reverse string method. And when we're ready to work with this, we can save it all. That's fine, just save everything out. Also, your JavaScript gets generated, so there's an interface for each of the function calls to give you a nice little test interface. And we can go and run this locally and start it, and it gives us a firewall notice about port 8085. And we can go into our connection, DataSnap driver, to also work with, which is built on the DB Express framework. So I said 8085, I think, and HTTP for rest, so it's connection succeeded. We can go to advanced, and we can look at different settings. But otherwise, we say that's okay. And then we can go and actually look at the interfaces. So we'll go and look at the function interfaces. Here's all those administrative functions that are built in. And we've got some two of our own custom methods that we can make remote procedure calls. So here, we can go and test this one by looking at the parameters. And we can go and put a value in. For example, this one is our echo string. So if we type hello world, and this will execute the method, it gives us the answer back, right, which is the same thing called hello world. And we can also do the same thing with the reverse string method. Let's go and give it a value we send over. So here's hello world, and then when we call the interface, it echoes hello world backwards. That's reverse string. Now, if I want to deploy this to the cloud, we can deploy this to Amazon's. You put in your username and password of your Amazon Web Services account that you can create through Amazon. I put in my username and password, and now it tells me what regions are available from Amazon. So it's querying the Amazon API for that. I've got my server on US West, so we'll choose that one. And it tells me here in a moment which machines I have available, and I have one instance running. And so there's my US West instance with that IP address. And then I can go and pick a file. So for example, that executable, project 20 there. And I need a shared folder, and I have a shared folder on my Amazon instance called DataSnap, and any other files that we want to deploy to it as well. And then we hit next. It says, okay, here's the remote location it's going to go to, and we hit the deploy. And we look at our DataSnap shared folder. We should see that that project20.exe is now hosted over at the application. So it deployed our executable, and then I needed some other files, and I need to open up that port 8085 as well. Let's open up, let's close this one. That was just to show you how to build something and deploy it up there. Let's go and look at this Azure demo. We have a connection component, and down here inside RAD Studio for Delphi and C++ builder, there are 4 components: a connection string, blob management, table management, and queue management. And we've got a user interface application that lets us look at all 3. And over here, if I'm in the blob world, I can upload a file to my blob as well. Let's take a look at this. And all it's going to do is it says, take the blob service using the connection info. So we'll call T Azure blob service. Use the connection information that came from the connection component. And then we're going to create a string list, and we're going to put the blob, whatever it might be, for that file based on, we give it a blob name, and then the file, which is going to come from choosing a file, a movie, a picture, or whatever. And we're going to put that block into the blob of a specific name that we give it, and then we're done. And the same thing for getting information, getting the XML from the list of containers from the interface, and displaying those elements that are in our container for the existing blobs that we might have by iterating through the different nodes in a blob. And here we'll use the XML doc component to do that displaying, to get the name and the URL for it. So let's run this application. Again, this is a client application that's running on my desktop, and it's going to let me navigate through the 3 parts of Microsoft Azure. So inside of these message queues, I can add something. So as part of the component interfaces that we provide, you can add a queue, and you can add a message to a specific queue. So we'll go in and we'll add a queue. This is the webinar message queue. And in the webinar message queue, let's add a message, and it might be hello attendees. And so now we've got the string, we double click on it, it gives us the message ID, the insertion time, does it have an expiration date, and the message text. So this message text might be, you know, some kind of XML. It might be, you know, something, might be some simple data packet that you would parse and use for some operation that's going on. For tables, we just create arbitrary tables. So let's go and view the data. It's got a name for the entity, and then we've got a key for that row and a partition key, and then you just key in values. So we could go in and add another property. Think property like columns, for example. So this is my age. Let's click in it. And I'm 59 years old. Sorry, you guys now know that. In 32. And it also takes grids and date, time, and just binary data that you can specify. And now that's part of this entity called name.intersimile. It now has the age in it. So you can build up your own metadata and build up your own tables interactively and in code using the API as well. And then we commit that change, and now it's there, and you can come back and get it. And in the blob storage, we've got some blobs here, so different things like there's a set of movie or pictures. Here's this JSON, and then we can see the properties of the picture. It's a picture of Jason Folks and myself. It says it's a block blob, what its content length is, some metadata about it that we can query. And again, this tree is being filled by the interface to the underlying Azure blob API. So the submitter, here's the file name where I stored it, where it came from on my machine. Here's additional information, the length of it. So this looks 121K for a bitmap, not bad. And this Azure application ships with RAD Studio XE. On form create, I had it load up my key. So there's two parts of an Azure key, you know, the name and the password. And so I've got an INI file that so that I don't encode my username and password in my executables. I load it from an INI, load the strings, so my Azure key, and then in the connection info properties, the account name and account key, I just store what comes from the INI file. Here's an example that uses S3. Tim Anderson, who's a writer in the UK and blogger, and I've got a link at the end to his blog. I think it was 3 years ago or so, he did an article about how you could use Delphi to talk to Amazon's S3 storage system, these buckets, and being able to stick things in the buckets. And the example appeared, and the article appeared in PC Plus magazine. And what I've done is I've taken what Tim did and I've made sure and updated it so it works. With RAD Studio XE. He had done the work, I think, at that time in either 2006 or 2007, and then he's updated it somewhere along the way. But I made sure it worked with XE. And so this application, one of the things on form create, I do the same thing. I open up I have my keys to get to S3 in an INI file, and I use that to connect this to S3 storage object by using the public and private key, and then I can use that instance along the way. There's a little message here. If it doesn't have a key, then it says no key is set. You must edit the S3 app INI to use this application. Of course, you must sign up for Amazon S3 storage to do that. And then there's a bunch of calls for saving, for example, using the stream to save from a bucket to a local file, or load from a bucket from a memory file into the S3 storage, and a set of methods for going, you know, do you want to delete the bucket? And then if the answer is yes, then it just calls delete bucket, and you give it a bucket name. And so the API, pretty straightforward for calling. Of course, underneath it's making HTTP calls to S3 to call the API and pass the bucket name and actually do the work. So let's look at this in action. So for example, I could list all the buckets that I have. So out on S3, I've got a set of buckets, and the buckets have names and creation dates and so on. Or over here, I see the buckets, so I've got a David I bucket, and then I can look at what items are in there, and I've got just a blank item, and I've got actually a bitmap, which was a polar bear cub in the snow. And we can go and delete items. We can get files from S3. So, for example, here's this polar bear JPEG that we stand out. So this is, again, just a Delphi app. In this case, we do it in C++ Builder as well, calling into the Amazon S3 storage system to add items, delete items. If I go to my browser, here's an example. Pavel Glowacki, who's our excellent senior software consultant in the Europe area, Europe region, he gave me a link to an item in his bucket, which is and displaying JPEG of the triggerfish from the fish fact example. So here's his S3. He's got it on EU West server, and it's Pavel bucket is a storage bucket, and you can actually just use HTTP, and knowing the file that's in a bucket in S3, if it's a bitmap, for example, or something else, it would display using the browser. Again, over here, it's controlled, and you can use the management console for Amazon to go and look at all the different buckets. So if we go into the David bucket, it'll say there's that polar bear item again. Right? And then some just arbitrary 125 byte storage. I think I just put a string inside of it. And once you have the API, then you're writing some Delphi or C++ code, or for that matter, you can use Delphi Prism or RAD PHP. It's just HTTP calls underneath to these different storage systems. Pavel's got an application, which is a customer application, and you can actually hit this very nicely from Firefox, but he's got a web application, a DataSnap application that uses jQuery and DataSnap, and he just put up the article and video about this in his Delphi Labs. I'll give you the link to that in a moment. And you can actually go in and look at customer information. So here's some customer information from a database that he has, and you can click and expand and collapse things. And you can hit that as well. It's 79.125.25.31:8080. All this is just, if you notice, you're clicking, look on the URL, it's just URLs that are passed, and his DataSnap server application will call the right interfaces from JavaScript and go to the DataSnap server. It'll do the database processing, database work for you, and return the HTML back. We'll take a look at that here in just a quick moment. You can also hit this from an iPhone or an Android phone. It's generating the right stuff to give you a nice interface experience on those devices as well. So he's got his DataSnap server, which is sitting out here, and some server inside of the server methods. He's got the employee database connection. He's got a SQL query that goes to the employee. It's just select star from customer, order by customer. And he's got a dataset provider. So the dataset provider is going to provide to something, to a client application or to the interface, the metadata and data that's associated with the customer query. So the dataset provider talks through the dataset, and the dataset talks through the database connection, in this case the SQL connection. And then in his server container, he's got the DataSnap server, he's got a TCP/IP transport and a server class. And then he's got just the user interface here for his server when it's running. And this is the server that he's deployed to his Amazon EC2 Windows server. And then we have a client application, and that client application will well, first it didn't like the socket connection, but that's okay, we'll just say no. So it's going through his driver, through his SQL connection for DataSnap, and then he's got the provider connection, which is going to the server methods which is T-server methods 1 on the server. Then he's got a client data set that will buffer the data locally, and the data source will feed the user interface. And he's also got a web client front end. So in the web, in the server unit, he's got, this is that web server, so he's got a web server version of the same application, which is the one that we'll connect to here in a moment. And he's got a markup provider that, again, is going to do the same thing as the native code multi-tier server that would run not on a web-based interface that does the same database operations. And then underneath, he's got the processing that goes through the data and will send back HTML to whatever client talks through it. And here's how he displays up the customer information, the contact information, and so on. So, if you choose to call the output customer detail page through a remote procedure call from your web client or your Windows client to the server, it will echo back the HTML that we saw when we brought up the browser talking to it. All right. So Pavel's got this. It's in his latest Delphi Labs installment. I've got the link to that as well. And he gives you the source code to it for both the Windows server, the Windows client, and the web DataSnap server front end as well.
Okay, so let me get back. Let's see how I have to remember how to get back to okay. Where's the WebEx? Oh, here we go. There we go. So coming back to the slides again. Here's the reminder of the URLs for that Fishback demo. You can hit that from an iPhone, an iPad, an Android phone, or from a browser, or you could build a client that has a browser container. And there's the URL again for Pavel's application as well. These are sitting out on 2 different Amazon EC2 servers. Here's the URL to get to his S3 storage to get that picture of that nice little fish. So cloud architectures and cloud infrastructure systems are popping up all over the place from some of the largest vendors, IBM, Dell, HP, Microsoft, Google, Amazon, and others, EngineYard, Rackspace. There's a bunch of these out there, and you should explore all of them and see what they have to offer. You can build your applications, or maybe you keep your applications close and put your data, or more likely your sensitive data you'll keep close, and you'll scale out to the applications. Or you may have them as backup data centers. Imagine something bad happens to where your data center is, and you want to make sure, just in case, that you have a backup data center running somewhere else. Put it out in the cloud, have it in standby or pause mode so that you can switch over to it quickly, or have it running so that you can always fail over very nicely, change IP addresses and things of that kind. What this allows you to do is just scale up. You might have a cloud infrastructure where you have one instance running, but you'll know that at midnight, or you've got some special contest running, or some special offer happening where a lot of customers are going to be hitting your site. Maybe you'll do that like that home shopping network kind of thing, where you have a special offer that's only good for the next 10 minutes. You might then use the interfaces of these cloud systems to spin up or start up 100 instances of your application servers for the next 15 minutes to handle the load, and then spin them back down. Because, of course, as they're running, you're paying, and as bandwidth is being used and connections are being made and data is being transferred, you're being paid. Sort of like that old time-sharing world, but in this case, you control everything within the server instances that you have. So you've got this scalable on-demand system that you can provide. There's APIs for starting instances, pausing them, stopping them, deleting them on lots of different cloud infrastructures around the world. Great thing is you can use native code completely. You can build whole native code application servers and then use the power of the internet protocols of TCP and HTTP, use service architectures like SOAP and REST, as well as using AJAX for highly interactive browser clients. All of that is provided for in RAD Studio, and in many cases, just by dragging and dropping components and using wizards and defining methods, all the JavaScript and AJAX calls will be generated for you. So you only then have to focus on the user interface of your clients, whatever those clients might be. Maybe it's a browser client or a native client or a mobile client. And you have access to all sorts of database platforms. There's, I think, Informex and DB2, and those are running in as options in the clouds. MySQL can be in the cloud. Microsoft is providing their SQL Azure, and IBM, DB2, and so on. So we have all of the database access we need if we want to use a cloud infrastructure and architecture. Or again, we might have a hybrid system where it's running inside and outside of your firewall. We have special offers happening this quarter. If you have an older version of our products going back to almost the beginning of time, you can upgrade to the latest versions, our XE versions, until the end of this month, end of May. Those special offers available, you can see what the information about, but you go to Programmer's Paradise and get all of that. We have, if you buy Delphi or C Builder, we'll give you RAD Studio. We'll give you all the programming languages, and that offer is running until the end of June. And we also have a product we call DB Power Studio for Microsoft SQL for developers at a nice special price, and there's all sorts of offers. And again, go to Programmer's Paradise to see what those offers are as well, and they'll fulfill that. Lots of links here. I'll have to post these on my blog. And also, Programmer's Paradise, they'll have the replay. They're recording all of this, and they have the slides so they can put them up for you as well. Because, you'll never be able to type in all these, but there's lots of links to things you can explore. The information about Amazon services, Google App Engine, Salesforce.com is going to create a database portal for people to use with APIs. Underneath the covers, they'll generate the SQL and return the results, and they're going to give developers some data storage for free up to a certain amount, and then you can pay for more if you need that. Underneath, it's a SQL server. I forget if it's Oracle or something else, but as far as developers are concerned, call an API, send the things that you want it to do. It'll generate the SQL underneath and return the results for you. Tim Anderson lives at itwriting.com out of the UK, does lots of writing about developer topics and what's happening in the developer world. So you can check out his blog at itwriting.com. David Linthicum does a lot of blogging on his InfoWorld blog about the cloud. He's not related to any specific vendor, so he'll give you really good advice and cross-platform, cross-cloud advice and information as well. He's not beholden to any architecture, any vendor, or any style of doing things, but really insightful and a lot of information for developers if you're exploring cloud computing as well. And then I need to do more of this, but I've done some Computer World blog, and you can look for my 3-part NoSQL. It's called, you can just search for the end of SQL and relational databases, and you'll find a 3-part blog that I did for Computer World, which gives you an overview of all these different NoSQL databases that are available, or at least were available last year. And with that, I'm going to turn it back over to the nice folks at Programmer's Paradise. That's my email address there, and we're ready for any questions you might have. So back to you. There we go. They've taken control.
Thank you. Go ahead.
If anybody has any questions, feel free to enter them into the Q&A or the chat, and we will take those if you have any.
Thanks, David, for doing this webinar for us today. We certainly appreciate it. We also thank everybody for attending today. Seeing no questions, we're going to end today's session. If you need to contact us, please do so at info@programmers.com or at www.programmers.com/Embarcadero. Thank you very much, and have a great day. Thank you.
Okay, thanks, everyone.